Image intensifier tube, also known as II tube, is an electronic device used in fluoroscopy system. It is usually placed above the patient as well as the opposite of an X-ray tube. An II tube is a vacuum tube which is placed inside of a metal housing. This device is important as it is used to convert low-intensity attenuated X-rays into high-intensity light image. Now, let us see the elements of which are insides of these vacuum tube. Here we have the input window, input phosphor, photocathode, anode, output phosphor, output window, and the electrostatic focusing lenses. The X-ray beam that has been transmitted through the patient's body enters the II tube through the input window. This is then get absorbed by input phosphor. This input phosphor is a fluorescent screen that receives the X-ray photons and emit light photons. That means this layer is converting the energy of X-rays into visible light. The photocathode is coated on the inner surface of the input phosphor, which is a thin metal layer. When light from the input phosphor strikes the photocathode, photoelectrons are emitted in numbers proportional to the brightness of the input phosphor. This anode is also known as accelerating anode. This is actually a circular metal piece with a hole in the center to allow the flow of electrons towards the output phosphor. Next, we will look into electrostatic focusing lenses. These are negatively charged electrodes that focuses the electron beam towards the output phosphor. The electrons emitted by photocathode are accelerated towards the output phosphor by an electric field produced between the photocathode and anode. Now, these highly accelerated electrons hit the output phosphor and produce huge number of light photons. This light in turn will be captured by the image capturing device like the Vidicon camera. The brightness of the output phosphor light is much more higher than the light produced by the input phosphor. So this is how an image intensifier tube generates a high intensity light image. Thank you. Next, we will go through the phosphor spectral emission and the absorption efficiency of an image intensifying tube. As we know, X-ray is transmitted through the input window, which are converted into fluorescent light photons by the input phosphor. The thickness of the input phosphor layer affects the spectral resolution and X-ray absorption efficiency. We can conclude that a thicker phosphor layer has higher X-ray absorption efficiency, which means more X-ray photons can be absorbed and converted into light photons in the phosphor layer. Next, when the electrons strike the output phosphor, the energy is converted back into light photons, thousands of times brighter than the input phosphor due to its smaller size and additional energy given to the electrons when they are accelerated through the image intensifier. These electrons that strike the output phosphor result in the emission of a large number of light photons, which is around 2000 luminescent photons are generated for every 25 keV accelerated electrons. The emission spectrum of these light photons is around 530 nanometer, which is green light. This matches well the sensitivity of most autochromatic film and video targets. This luminescence decay time of the output phosphor determines the temporal resolution of the image intensifier. In conclusion, we can conclude that phosphor spectral emission allows the intensity of the final image to be several thousand times brighter than the initial image created at the input phosphor. And as for the absorption efficiency, higher the absorption efficiency, lower the amount of radiation dose being exposed to the patient.